This video is going to talk about area on the coordinate grids. Let's find the distance between these two lines. By looking at these two lines, we can see that there are 2 steps between the lines, so the distance is 2. How did we find the distance between there? Well, because they were both on the grid, we just measured the steps between. We drew a vertical line and measured the distance. So we could also have a method using the coordinates to find the distance so that we don't have to draw them every single time. So if I want to look at the distance here, we can see that I drew another line to measure the distance between. What do all the points on that upper line have in common? Well, they're all having a y coordinate of -1. Doesn't matter how many times you run to plot something on this upper line right here, at the end of the day you're always going to jump -1 to get to this line. To get to this line, doesn't matter how far you run, you're always going to have to drop -3. For the record, on this line right here, you would always, doesn't matter how far you're jumping on this one, you would always be running 1 and then jumping somewhere up and down this line. One of these lines passes through 1, 2.3, the other passes through 2, 4.5. What's the distance between these lines? They're looking for a subtraction sentence. So if I see that one of these lines passes through 1, 2.3, I'm going to know that I'm going to run 1, which doesn't really matter for figuring out which line we're looking at, but I'm going to jump 2.3. So this first line, let's call this A, is going to be the line that is the 2.3 line. The other line is going to be letter B. That's going to be the one where we're jumping 4.5. To find the distance between these two lines, we want to subtract 4.5 minus 2.3 so that we would know the distance between these two lines is 2.2. How do we know this? 4.5 minus 2.3. How could we use the coordinates to find the distance between these two lines? Well, I would plot a point on either one of the lines. Let's plot, let's say this point, and let's say this point. In fact, you know what might even make it easier? Let's plot the points on the same vertical line. That way we have less to look around at. So I'm going to plot 2 points on this line, on these two lines. The first point up above, I had to run -3 to get there, and then I jumped up 3. The second point, I had to still run -3, but then I jumped -1. So if I had to run the same time both times, that doesn't help me find the distance between. But for the first line, I had to jump 3. The second line, I had to jump or fall -1. So to find the distance, I would take that 3 plus 1. But how did I know it was going to be +1 instead of +1? Remember that we're just looking at the distance. So this is 1 step away. So this would be actually the absolute value of 1. And this is 3 steps away, or the absolute value of 3. The 1 here and the 3 here ends up being a distance of 4. Let's find the distance between the horizontal lines passing through 2.51 and 3.4, -2.1. So let's go ahead and let's plot these lines. Remember that we're going to be looking for horizontal lines. We're going to take that into consideration in a minute. So to plot this first point, 2.51, I'm going to run 2.5 and I'm going to jump up 1. I know this is a horizontal line, which means it's going to be a straight line all the way through, well, it would be a straight line if it wasn't on this, all the way through here. Then I have 3.4, so I'm going to run 3.4. I'm going to jump negative 2.1, so I'm going to fall 2.1. Because this is another horizontal line, I'm going to plot that. Do I care so much about how far I had to run to plot these lines? Not so much. Because I knew that they'd be horizontal lines, I could have run any direction so long as I jumped the same distance. So I jumped 1 to go here, and I fell 2.1 to go here, which means my total distance is 3 1/10. Go ahead, try to find the distances between these vertical lines by looking at these points. Now remember, back up here for the horizontal lines, I didn't care so much how far I had to run. I cared how far I would need to jump to get that line up there. So for a vertical line, I don't care how much I have to jump. I care how far do I have to run to get to my line, because I know it's going to be an up and down line, and I kind of have to figure out where am I going to place it on here. So I'm going to be looking at my run numbers for these. So for letter A, if I had to run -2 to get to the first line, that was horizontal, and I had to run -4 to get to the second line, that was horizontal, the distance between -2 and -4 is 2, because it's only 2 more steps to go between them. If I look at letter B, -2 to -5, well, if I look at how far I'm running there, -2 is 3 steps away from -5. They're both on the same side as 0, so I'm just subtracting the digits from each other. 5 minus 2 is 3. If I look at letter C, 2 to -3, these are on 2 different sides of 0, which means I'm going to add the distance it goes from 2 to 0, which is 2, plus the distance it takes to go from 0 to -3, which is another 3 steps, which means that together we're going 5. Same thing for letter D. We would go ahead, and because these are on 2 different sides of 0, we would want to make sure that we are we would want to make sure that we are adding up these numbers. So we'd want to go 4.75 steps and another 2.11 steps. That would end us up with 6.86 steps. How do you take 86/100ths of a step? Don't know. That's the magic of coordinate grids. So we can also find the areas of parallelograms and trapezoids on a coordinate grid. Remember that to find the area, you need to know the length of the base or the bases and the height. The height is the distance between the bases, so that's where those distance between parallel lines comes in handy. So we have the points, and I did not write these ones down. I had them down for the other video. We had the following points here. We had A is -3, 1, B is -1, 5, C is 4, 5, and D is 2, 1. Take a look at these questions on here and give your best answer to them, and we're going to figure it out on the next screen. Does this parallelogram have horizontal or vertical sides? Do you see any sides that share the same run or the same jump? See if you can figure out which ones they'll be. What is the length of the horizontal sides? Try to figure out what that length might be. How would you know that? What is the height of the parallelogram? The height of the parallelogram is the distance between those 2 sides. So make sure that you're not just finding anything, make sure that you're looking at the 2 vertical sides. Then we're going to check your answers by drawing the parallelogram itself. So let's go ahead and draw this on the graph right here. Point A was -3, 1 for point A. Point B was -1, 5. Point C was run 4, jump 5. You might be able to start seeing some of your same sides here. And point D was 2, 1. So if you noticed that BC were on the same horizontal line and AD were on the same horizontal line, excellent. You might have noticed that they share the same numbers. We have AD and we have our BC here. Now, how do we tell the distance between them? Well, what's 5 minus 1? 5 minus 1, 1, 2, 3, 4. You can see that the height right here is 4. So if the height is 4 and each of the bases are how long? Well, look at the distance between there. What is the distance between the bases? 1, 2, 3, 4, 5, which you could also see by looking at the coordinates. We would know that the area of this shape is 4 times 5, or 20 units square. Now we have a trapezoid. See if you can find the same numbers in the trapezoid. Do you think it will be a horizontal or a vertical same line? You might notice the 1 and the 1, the -2 and the -2. Do you think they will be horizontal or vertical? What is the length of the sides? How do you know? What is the height of the trapezoid? Remember, the height is going to be the distance in between the bases. So then they want us to draw the trapezoid to check the answers. So we're going to have -2, -1, -2, 4, 1, 5, and 1, 1. So let's go ahead and let's graph this out. So if our first point, E, is -2, 1, we would have run -2, fall 1 for this point E. Point F was -2, 4, -2, 1, 2, 3, 4. Point G was run 1, jump 5. And then point H was run 1, jump 1. And here you can see these horizontal lines right here. And you can see that there is a difference in the direction of these sides. So with our trapezoid, what is the height between these two sides? If you saw back here that -2, the absolute value of -2 and the absolute value of 1 added together are 3, you are correct. 2 steps to get to the line, another 1 step to get past it. Remember that it's important to know whether the shape is a parallelogram or a trapezoid to know which area formula to use. The area of a parallelogram is base times height, and the area of a trapezoid, they like to write it like this. I like to say the area of a trapezoid is half of the base 1 plus the base 2 times the height. It's just switching the order around. Either way works. So remember how to decide whether a quadrilateral has 2 vertical or 2 horizontal sides, and figure out how it's a trapezoid or a parallelogram. If the side lengths are equal and parallel, the quadrilateral is a parallelogram. If they are parallel but unequal, it's a trapezoid. Since you need to find the length of the base or bases, this does not really create any additional work. It's just checking the distances between each one. Go ahead and find the area of the shapes from the previous exercises if you so choose. Just going to kind of look through the rest of here so you have the opportunity to check it out. Ladies and gentlemen, I hope that the rest of your day is absolutely as amazing as you are.